We load 3 classifiers for the heart disease detection dataset. In this scenario, false negatives should be avoided. It is also a scenario where a no prediction option is viable to reduce the risks. 3 classifiers have similar performance in most metrics. However, the random forest model has lower recall. To explore this, we can select its errors and see that they are mainly in the true class. We can look at the rejection curve for recall and see that it is not possible to achieve as good performance as we do with the other classifiers. We remove it from consideration. We can select the errors of logistic regression and k-nearest neighbor classifiers by using cyan and pink selections. It shows these 2 selections have similar distributions across classes. The reliability curve shows that they are both well calibrated. We use performance confidence view to look more closely. We see that K&N classifier has many false negatives with extremely low scores. If we select these errors, we see that logistic regression also gets these items wrong, but is much less confident in these errors. The rejection curve view allows us to compare the classifiers. While they have similar performance without rejection, the LR classifier improves as the rejection rate is raised. We select the LR classifier as it allows us to make trade-offs between performance and rejection. We need to choose thresholds that balance performance and rejection. The bandwidth assessment view and uncertainty heatmap view provide summaries of possible ranges. We can interactively experiment with different thresholds to see which gives the most appropriate trade-off. The rejection curve view allows for detailed choice of rejection rate. For example, we find that we can achieve perfect recall along with acceptable precision and rejection rates by choosing appropriate thresholds. We can assess the fairness of our tuned classifier. We select the errors and see that there are similar rates between males and females. However, when we select the rejected items, we see an imbalance. The classifier is more likely to be uncertain with men. To explore this, we select men and women as separate selections and compare their reliability and rejection curves. We consider 3 different models to identify flowers in an image classification dataset. The reliability curves show very different calibrations. Using the bandwidth assessment view, we can choose appropriate thresholds for each. The rejection curve shows good performance improvements at a 10% rejection rate. With these settings, the modules are similar in performance. While they reject the same number of items, they reject different items. We can select the small number of false positives and examine them in detail. We can step through the images one at a time. For several images, we see flowers, but with insects on top of them. These images are labeled as insects and are therefore considered errors.